So finding c for the perfect square, then factoring. So this is kind of a lead up to completing the square, which helps us get quadratics into what is called vertex form. And so c is a number we build, and it's specifically built by taking our b term, dividing by 2, and squaring it, remembering that a, b, and c come from the general form of a quadratic. So a is our term in front of our x squared, b is our term in front of our x, c is our term by itself. So we build this c specifically so that's a perfect square. But here's something to know. Before we go about building c, a, if it's not, a needs to be a 1. If it is not, then factor a out. So what this means, I'm going to show you an example of this. So if I was given, for example, x squared plus 4x, I could automatically go about finding my third term for c to make it a perfect square because this is already a 1. But if instead I was given 2x squared plus 10x, I can't go about finding c yet. This first term needs to be a 1. So since it's something else, we pull out whatever it is. We're pulling 2 out of 10, we factor it out, so that means I have 5x left, and now at this point, I can add that c term because this spot is a 1. That 2's been factored out. It is no longer in play, it's out front. It just hangs on for the ride. So let's walk through some of these. First off, if we had x squared minus 8x, and we want to find our c, that third term to make it a perfect square, we take our b, negative 8, divided by 2, and square it. Well, that's just negative 4 squared, which is 16. So in other words, if I had a quadratic that looked like this, it would be a perfect square. And if we factor, it actually factors into x minus 4, x minus 4. Or, since they're the same, x minus 4 squared. We've built that c specifically to do that every time. And a key thing to note is we don't actually have to factor this at this point to get to here. There is a way to know, because of the way we built it, what that number is without factoring it. Every single time when you complete the square, this number will always be the number you get before you square your b divided by 2. Always. This helps us when we start completing the square on things like fractions, so we know what that b is, or what this factors into, without actually factoring, because it follows this pattern. So for example, 2x squared plus 20x, and we want to find that c. So this is not a 1, so we factor it out front. We'll find that c now, so we're going to find c. So to find c, we take our b, our middle term, divide it by 2, and square it. So we have 10 divided by 2 squared. Well, that's just 5 squared, which is 25. So 2x squared plus 10x plus 25, this piece inside is a perfect square. It's going to factor to be 2 identical binomials. So they go as x and then this number before you squared it. So plus 5, because it's positive, squared. And this 2, once we factor it out, just stays on for the right. It hangs out front. Let's try one more. We've had nice whole numbers so far, so let's go into the realm of fractions. So we have this. First off, a is 1. Our front number is a 1. That's great. That's what we need. So we can go about taking our b, dividing it by 2, and squaring it. Well, 11 divided by 2 is not a nice whole number, so I'm going to leave it as a fraction. Well, 11 squared is 121, and 2 squared is 4. So in other words, what I'm going to add in that c spot is 121 over 4. Okay? So now I've created a perfect square trinomial. I've created something that's going to factor to 2 equivalent binomials. So it's always going to be x. So in this case, the number I had before I squared it was 11 halves, and it was positive. Okay? So sometimes with fractions, especially in this case, would you want to go about trying to factor this? Probably not. So since we know we created a situation where it always factors to be this way, it's a nice way to remember it without having to go through the whole process.